Hey everyone, thanks for joining. I am Kanchan Bharati and I am a senior program manager here at Microsoft in the Azure Posette product team. Welcome to this talk on what enterprises like about Azure Database for PostgreSQL. This session would be really helpful for the customers who are planning to migrate their on-premises workloads, especially Postgres workloads, into Azure, as well as our single server customers who are planning to migrate from single server to flexible server. So let's dive in. And as part of the session today, we will dive into managed service features, especially in our flexible server offering that our enterprise customers love to use. Some of these features include high availability, security, reliability, connectivity, performance, etc. Apart from this, I'll spend some time on discussing our AI capabilities on flexible server and how you can leverage pgvector and Azure OpenAI. By the end of the session, you will learn why Azure Database for Postgres Flexible Server is becoming more and more popular with our enterprise customers. So why PostgreSQL? PostgreSQL has a rich history that spans over 3 decades, and it is loved and supported by open source community. In 2023, it is ranked as one of the most popular databases in Stack Overflow developer survey. In fact, it is consistently featured in top 5 most loved databases in DB Engine rankings. And here at Microsoft, we are deeply invested in Postgres. But when you think about databases at Microsoft, Postgres probably might not be the first name that comes to mind. Microsoft is known for building world-class databases like SQL Server, for Synapse, Cosmos DB, but many don't know that we are equally invested in open source workloads. Today, over 60% of our virtual machines run on Azure use Linux cores. We have 47,000 customers trusting Azure and choosing to run their open source workload on our databases. We are deeply invested in open source Postgres in terms of our open source contribution as well as the managed service that we run in Azure. Last year, we started publishing a half-yearly blog that details everything that we are doing at Microsoft with respect to Postgres. The latest edition was recently published in the month of May, and it is a great way for us to share all the important activities that we are doing with the community, both with respect to our open source contribution as well as managed service. On a very high level, we have 5 committers, 9 contributors, and we have released more than 60 patches in the last 12 months. This blog also provides you high-level details about all the upcoming work that the team is doing as part of Postgres 17 release. I highly encourage you all to go and read this blog and provide your great feedback. So when we think about managed service on Postgres, we have 2 important set of customers, enterprises and developers. When we talk to enterprises that are migrating their workloads to cloud or simply evaluating managed services to migrate to, they talk to us about security. They talk to us about availability, reliability, etc. They want to have a trusted platform where they can run their mission-critical workloads day in and day out. On the other end of the spectrum, we have developers who need cost-effective access to bits. They want all the latest versions to be readily available so they can start testing it. PostgreSQL is a phenomenal database, but it can be even more powerful if it can leverage capabilities that exist in cloud. These capabilities could be fundamental capabilities like cloud storage or all the latest innovations happening in AI with pgvector and Azure OpenAI. Here are some of the high-level benefits of using Azure Database for PostgreSQL. You get maximum control for your database, like with your network isolation with VNet and private endpoint. You can tune your Postgres flexible server using server parameters. You can customize your maintenance window based upon your business requirements. Additionally, in terms of resiliency and availability, we allow you to configure zone redundant HA that gives you 4 nines uptime SLA. Apart from this, we also support fast failovers with 0 data loss. And for your latency sensitive applications, you have the ability to co-locate your application and database within the same availability zone. Coming to our developers, we give ways to start and stop servers, use bustable compute to reduce their total cost. And also one of the most important factors is we allow customers to use community version of Postgres, which is not a fork. So there is no vendor lock-in. So if you want to migrate your Postgres workload from on-premises to Azure or vice versa, you have the flexibility to do it. We recently conducted a case study with Enterprise Strategy Group to examine the potential cost savings of migrating on-premises Postgres workloads into Azure, and we saw 62% cost reduction when migrating these workloads. In fact, if we add the modernization layer on top of it, the customers are seeing more than 84% total operational cost reduction. This is a perfect example of how Azure managed OpenShift databases can reduce your total cost of ownership when migrating your workloads onto Azure. So let's dive into high availability and disaster recovery. So here is the Postgres flexible server architecture. If you see, we deploy Postgres flexible server on a Linux VM, and we store the data in the premium files, Azure Premium Storage, which maintains 3 copies of the data. So the data is highly redundant, and just in case if one data block gets corrupted, you can always rebuild the data copy using the other 2 blocks. Apart from this, we give you the flexibility to co-locate your application within the same AZ. So your application could be running on an Azure VM, AKS, or app service. And we stored all the database backups in highly durable zone redundant storage. So just in case if the complete AZ goes down, you have the flexibility to do a point-in-time restore using the ZR storage into a different availability zone. Now let's talk about compute and storage. With a flexible server, you get 3 types of compute tiers: burstable, general purpose, and memory optimized. Burstable compute tier gives you 2 gigs of memory for 1 virtual core, and this is usually suitable for workloads that don't require full throttle of CPU. Coming to your general purpose, this is most commonly used by most of our customers. It gives you 4 gigs of memory for every 1 virtual core. Finally, at the high end of spectrum, we have memory optimized queue, which is suitable for faster transactional processing or workload that requires high concurrency. And you get 8 gigs of memory for every virtual vCore, and you can scale up to 672 gigs memory and 96 virtual vCore. Coming to storage, we offer 2 types of storage with flexible server: Premium SSD and Premium SSDv2, that is currently in preview. You can scale up to 64 terabytes of storage. You achieve up to 80,000 IOPS and 1200 Mbps of throughput. If you see on the right, you notice that with 160 gig storage size, you can achieve IOPS of 80,000 and a throughput of 1200 Mbps. This is really important now because just to achieve higher IOPS, you no longer have to provision a disk which is, a bigger, drastically reducing your overall cost for your storage. The new Premium SSDv2 in Azure is simply stunning. When we compare it with our existing Premium SSDv1, SSDv2 are 4.5 times faster, allows you to reach up to 4 times more IOPS and scale up to 2 times the current size, which is up to 64 terabytes. But the most important benefit of using Premium SSDv2 apart from performance is its ability to scale in 1 GB increments, resulting in a lot of cost savings for our customers. As I mentioned, this is currently in preview worldwide, and we are expecting to do a GA release later this year. One of the other important features that most of our enterprise customers really love is the ability to perform near zero downtime scaling. With this capability, customers are now able to change their server size with flexible server with a downtime of under 20 seconds, which is typically very tolerable for any applications making connections using sufficient retry logic. So let's talk about backups. As you know, backups are really important for any organization. And as a managed service, we do the undifferentiated heavy lifting of managing this backup, running the backup, configuring and retaining them based upon the credential customers have configured. With flexible server, we provide 2 types of backups. One is the automated backup, and the second one is the long-term backup. With the automated backup, you have the ability to retain your backup from 7 to 35 days. And when you configure automated backup, we take daily disk snapshots and archive the WAL files to Azure Blob Storage. But we do have enterprise customers, like financial customers, banks, etc., that have a compliance requirement to retain the backup for more than 35 days. In some cases, 1 year, 2 years, and up to 10 years. And to meet this scenario, we have rolled out a feature called as long-term backup that gives our customers the ability to retain the backup for longer duration using Azure Backup Vault. In terms of RPO, Geo Backup provides up to 1 hour of RPO. So there could be a data loss of up to 1 hour when you're using Geo Backup. And with automated backup, you get a RPO of less than 15 minutes. But if you have to meet aggressive RPO timelines, then we recommend using read replicas. In terms of durability, Zone Redundant Backup provides you 12 nines durability, whereas Geo Backup provides you 16 nines durability, because Geo Backups are actually copied to another geographical location. So you have multiple copies across 2 regions. So they are protected from regional failures as well. So coming to restore, customers now have the ability to perform cross-subscription and cross-source group restore. For instance, you have your production instance in one subscription and development instance in other subscription. You can perform restore easily using a point-in-time capability. You can perform it to same VNet or a different VNet, and you can perform to latest restore point, a custom restore point within your retention window, as well as you can perform a fast restore, which is basically restoring a full backup, just to recover your data very quickly. So whenever you perform this restore, first we restore the snapshot, then we apply the val file, basically replay the val file to complete the recovery process for you. Here is a zone redundant HA architecture for flexible server. Whenever you enable zone redundant HA for your flexible server instance, we spin up one more Postgres instance on standby. You have the ability to choose the availability zone. If you don't choose it, we randomly choose one of the available zones. And whenever you do it, we choose the identical compute and storage, and the data is synchronously replicated using native PG replication. And data has to be committed at least 2 places before the acknowledgement is sent to client. So as data is synchronously replicated, there is 0 data loss. And additionally, in the event of unplanned outage or whenever we are doing planned maintenance, there is an automatic failover to the standby instance. So this gives you a 4 nines uptime SLA. Coming to our disaster recovery, we offer 3 types of disaster recovery. Out of 2 are completely managed by our service, and 1 is customer managed. Geo Redundant Backup and Restore is a low-cost DR solution, but comes with a higher RTO and RPO. But if you have a DR requirement where you want to have a lower RPO and RTO, then we strongly suggest you to use either read replicas or logical replication. Let's dive into Geo Redundant Backups. The Geo Redundant Backups are available only in Azure paid region. So if you have your DR in a non-Azure paid region, then you should use read replicas or logical replication. Geo Redundant Backup is a low-cost DR solution because there is no server in the DR region. Only the backups are copied to the DR location. So whenever you enable Geo Backups, what we do is we take the daily full backups and the val files and we ship them asynchronously to the DR site. Let's see that in action now. So just assume you have deployed a flexible server in ECS 2, and the daily database backups and continuous val backup files are copied to the paid region, which here is Central US. And just assume there is an outage in ECS 2. As the backups are already copied to Central US, we will perform an on-demand restore, spin up a Postgres instance with the attached premium storage, and we will recover your data. So this is a low-cost DR solution for customers, and many customers love this because they don't have low RPO requirements, and this is usually suitable for many of our customers. But just imagine you have a different requirement where you want to meet more aggressive RPO timelines, or you want to have a DR in a non-Azure paid region. So with read replicas, you have the ability to achieve that. You can have your production instances in US and maybe your DR instances in Europe or Asia, because you have business units set up across the world. Apart from this, read replicas also gives you the flexibility to offload your read traffic, so you can reduce your load on your production system. As the data is asynchronously copied between replicas, the good thing is there is no production load. So basically, there is no production overhead when configuring read replicas. With read replicas, one of the challenges that we had earlier last year, especially for our customers who were performing frequent drill, was the inability to fail over and fail back very quickly. So whenever they were doing this GeoDR disaster recovery drills and they failed to standby server, they had to reconfigure the replication, wait for the replication to catch up before failing back, which was time consuming and resulted in a lot of customer frustration. We took that feedback and we worked relentlessly and rolled out this feature called as multi-region disaster recovery as part of Ignite last year. And this gives our customers the ability to run multiple machines under single virtual endpoint across multiple cloud regions. Now, as part of any planned failover and unplanned failover, you could switch back from primary to replica, and we drain the replication so there is zero data loss. And once that is done, application continues to run without any need to make any application config changes. So this is a really important feature that many of our enterprises really love and already using it. And it is very simple to use. If you go to your replica plate, and as you see on the right, there are two actions, promote to primary and promote to independent server. And you choose promote to primary and do a planned sync data before promoting. That allows zero data loss while using this feature. Finally, this is one of the very, very important features that I think more than 5,000 customers have already tried, which is called as in-place major version upgrade. If you ask any database, administrator or a developer, it is a painful process to upgrade from a lower version of PG to a higher version of PG. Either you use the PG dump and restore or use the migration method using logical replication, which is time consuming, involves a lot of effort and also a business downtime. With in-place major version upgrade, we simplify this experience. With one click of a button, you can upgrade from a lower version of PG to a higher version of PG. The beauty of this feature is this is not the size of data operation, which means that even if you're migrating a 1 terabyte or a 20 or 32 terabytes data, most of the upgrades usually finish in less than 20 minutes. And there is no need to change any server name or connection strings. And if there is a failure, just in case, or the data is automatically rolled back. So there is no user action at your side. And one of the other important benefits of using in-place major version upgrade is it gives you the ability to skip versions while performing upgrade. For instance, you are running a PG version 12 and you want to go to 15, you can skip version 13 and 14 and directly go to 15. And that works just fine. Now let's talk about AI. Azure AI is an extension that allows you to easily integrate artificial intelligence capabilities into your applications and workflows. This extension provides you a consistent experience to access Azure's AI services such as Azure Machine Learning, Azure Bot Services, Azure Language Services, etc. With Azure AI extension, you can use SQL interface to access Azure OpenAI and also create embeddings using SQL statements. One of the other important announcements that we recently made is the general availability of Azure Storage Extension. This allows you to enable import and export of data from Azure Storage. A common use case for Microsoft customers is the ability to export their data between Azure Blob Storage and Azure Database for Postgres Flexible Server instance. Thanks to Azure Storage Extension, our customers are able to do it, and our enterprise customers are already loving these capabilities. Now let's talk about pgvector, this wonderful extension that became so popular in the last year. pgvector fundamentally provides three distinct capabilities that allows you to take vectors, which are numeric representation of text, and store them in Postgres using native vector data types, index them, and then query them to find the distance between them, which is how semantic search fundamentally works. It is a great capability that allows building next-generation AI apps directly on your PostgreSQL instance. But there is a problem. Most of the database experts are deep experts in SQL. It is a language of their choice. When we have this ability to index and query them, this is all wonderful, but I can only use it after it is created. And this was basically a fundamental gap that we had. So in November, we shipped Azure AI extension, and I'm going to walk you through how that works. Imagine I got this simple table with some recipe data in it. I have this product ID, product name, product description, and product brand. Most of them are Vacha columns. And I would like to add a new column using the vector data type. This is where I want to store the embeddings for this text data. How can I do this in Flexible Server? I can basically create an extension called as Azure AI. And once I do this, I can configure the endpoint to Azure OpenAI service, which will give you access to all the capabilities. Basically, in this case, I'm looking for the capability to directly access the embedding models. Using an underlying REST API, I can pass the data from the database and get the embedding back and store them locally in the vector data type, as shown here. So once I configured it, then I can simply run a very simple SQL statement to update the data in the table, which are basically null columns previously, with these embeddings directly into the table. So this is what's happening. So now that I have created embeddings, this is fundamentally what is happening under the hood. I'm running an update statement and I'm passing that update statement to Azure OpenAI, and Azure OpenAI runs it. Typically, the response time is anywhere from 50 to 60 milliseconds. So this API call does introduce some latency. So you need to think about how you want to architect the application if you're thinking about putting this on a critical path of inserting or modifying the data in the database. So if you see here, the data is in the table. I have the embedding on the right side of the table, and I can now use these embeddings to perform semantic searches. Now let's dive into security and connectivity. With Azure Database for Postgres Flexible Server, you now have the ability to configure networking using public access or private access. Even with public access, you can restrict the access to your flexible server by using network security firewalls and client access list. And with private access, you have the ability to use virtual network, which is basically VNet injection and private endpoint. And you can either use a CM VNet or VNet, different VNet. And we also support VNet peering with flexible server. Entra ID authentication is one of the most asked used features by enterprise customers, especially the financial companies such as banks, as they have a strict compliance requirement to disable local password-based authentication that comes with Postgres. So with Entra-based authentication, customers can now use Entra IDs to log into Postgres instances. Apart from this, additionally, they can use Microsoft Entra ID groups and Sunrise principles to access the flexible server databases. So we also rolled out another important capability last year, which is customer managed key. Now customers can use their own managed keys to encrypt the data as first, and they can store these keys either using Azure Key Vault or using hardware security models from Azure. Finally, we recently announced the general availability of Microsoft Defender, and this helps you to protect against brute force attack. It allows you to, detect anomalous login patterns, and you can directly enable it by going to Security Blade on our flexible server blade. Coming to monitoring and observability, we have Azure Database for Postgres Flexible Server supports more than 60 extensions, and we have documented all the versions, all the extension versions that each Postgres instance supports. Apart from this, we give the customer the ability to customize their maintenance window. Usually, we have a 30 days gap between two scheduled maintenance, and we give our customers an advanced 5 days notification. And one of the most important items that I would like to add here is all of our minor version upgrades are part of our monthly maintenance. And we usually recommend our customers to schedule their production instances using custom schedule and leave the non-production instances to use system managed schedule. This ensures that their non-production instances are patched first before the production instances. Finally, we have server parameter control. Usually, these server parameter controls the default settings are suitable for most of the workloads, but if you have a requirement to tweak these parameters, we do give the customer the ability to tweak some of the server parameters, and you can do it based upon your application testing. We emit more than 70 monitoring metrics, and which are retained for 93 days. And all these metrics can be used for alerting. So you have metrics to report your IOPS, throughput, bandwidth, CPU consumed, etc. And one of the great capabilities is these monitoring metrics are directly integrated into, can be directly integrated to Grafana. So you can have your application, database all in one Grafana dashboard. And if you want to retain it for a longer duration, you can do it using log analytics as compliance research. Then enhanced login. Now we give our customer the ability to store server logs directly, in the form of text files, and you can use Azure Storage Explorer to view this file. Apart from this, you can send this, log file directly to Log Analytics workspace or to an Azure Storage account, or even to, just stream it to Event Hub. So I would like to leave you with some of Azure Postgres resources. So these are some of important resources that I would like you guys to bookmark. So if you see here, aks.ms/Postgres is our Postgres documentation. You can follow us on Twitter and LinkedIn. But one of the most important items is this Azure Postgres Feedback Forum, aks.ms/pg feedback. This is really important. You can actually, influence the product roadmap. There are many customers who are actually submitting whatever feature they would like to see in Azure Postgres Flexible Server. You can always submit your new request or, plus one the existing one. So this is a great way to, influence the product roadmap. Then if you have any questions, don't hesitate to reach out at Ask Azure DB for PostgreSQL. Finally, thank you. I hope this session was useful for you, and I really appreciate you all joining in here. Thank you.